Hello everyone, and welcome to this video about piecewise functions. But what is a piecewise function? Well, a piecewise function is actually just a graph that has different pieces of different functions on it. And that's exactly why it's called piecewise, because it has different pieces. So if you guys look at this graph on the side here, this is a function that has different pieces of different graphs on it. Part of it follows the function of x squared minus 1, and it follows it for the interval of -1 to 1. That's what that means. So it's going from -1 to 1. That's following that specific function, which is quadratic. That's why it's curved. And then in the second part, the second function that is also graphed on this graph is x minus 1. That's a line. So it's following that linear function from the interval from 1 to 5. If you are given a graph and you want to determine what the domain and range of the function are, remember that the domain is all the inputs that the function has and the range is all the y outputs that the function has. So let's start off by identifying the domain of this function. We're going to look along the whole x-axis and identify what points the function touches. All intervals run from left to right, so let's actually start off from the left. On the left-hand side, the first x point that has a value on it is 1, -1. And since there is a solid line or a point, that is included. So we're going to include that with a bracket. We're going to write our domain in interval notation. So we're going to start off at -1. And then we're going to just follow the curve. Just follow the function. And it seems like there are no breaks. So it's continuing, it's continuing, it's continuing, and it's stopping at this point here. This point is 1, 2, 3, 4, 5. So it stops at 5, and it is also included because it is filled in whole. So this is the domain for this function. There is an output for every one of these x values at from -1 all the way up until 5. Now let's identify our range. The range in this case is all the y values. So what y values does the function have? We have to start our interval from smallest to biggest, and smallest starts from the bottom. So we're going to go from the bottom all the way to the top. From the bottom, we can see that the first point that the function has, the point where we see some sort of solid line or a point or anything, that is at -1. So the range of our function is starting off at -1, and we have to put a little bracket around it because it is being included. The solid line means that it is included. And if we follow it, let's see, we're going to continue, and the function stops at this point. On the y-axis, this point is 1, 2, 3, 4. So it stops at 4, and since it is included, we also have to put a bracket around it. So we have just identified our domain and our range. If we aren't given a graph, however, we can identify the domain just by looking at the function. The portion that tells us what our domain is from the function is this part right here. The combination of these two tells us exactly what the domain is. So if we graph them out, let's graph them out on one axis. This is going from -1 to 1, and these points are included because of the less than or equal to sign. And it's the other interval is going from 1, and it's not included, and going up to 5, which is included. So if we combine both of these graphs and look at the overlap that they have, when we combine them together, we do get our domain is going from -1 up until 5. And that's what we got as our domain originally from the graph. For the range, however, the range actually comes from the output. So what you're going to want to do is plug in the x values into your function, and that is going to tell you what your range is. To find the range of different points, what we can do is make a table or just look at the graph, if we're given one. But if not, let's just take our numbers and plug them in. So the first point that we encounter is that x is equal to -1. So if we plug in -1, -1 is corresponding to the x squared minus 1 function. So we have to plug in -1 into that function to see what output we get. And -1 squared is 1 minus 1, that's 0. So our y output is just 0. And now we can do that for all the points in between. So this is going from -1 to 1. So that means that it's including -1, 0, 1. And we have to also think about what kind of function this is. X squared minus 1 is a polynomial. And that means that this has no restrictions. It has no restrictions as we talked about previously. So any number x can go into this function and we'll get an output. So we can also plug in 0, we can also plug in 1, we can also plug in anything in between here. So we can even plug in like 1/2 or -1/2. Basically any number between -1 and 1. I'm only going to find the outputs for the integers -1, 0, and 1, and also 1, 2, 3, and 4, and 5. Just to keep things simple. So if we plug in 0 into the function, 0 squared is 0 minus 1, we would get -1. And if we plug in 1 in, 1 minus 1, that's also 0. Now we can look onto the second part. The second part of the function follows the function x minus 1, and that's from the interval from 1 to 5. So for all the x values from 1 to 5, it's going to follow x minus 1. So for the value of 1 is actually not being included. Do you see the sign over here? That means that it's not including 1, so it's starting off at the next point, which could be like 1.1, 1.2, 1.3, any other number that's close to 1, but not exactly 1. So for the whole numbers, since I'm using the integer numbers, I'm going to start off by plugging in 2, and then 3, 4, and then 5. But you can also, like I mentioned before, pick any number in between, and that will be part of your range. So this 2 is now going to get input into the second equation. So this is going to be 2 minus 1, and that's just 1. The 3 is also going to get placed into there. So 3 minus 1, that's 2, 4 minus 1, 3, 5 minus 1, 4. So these are some of the outputs that we get. If we look at them from least to greatest, the lowest number that we have is -1, and the highest number that we get is 4. So that does coincide with the information that we got about the range. But to get the most accurate range that you can get is by looking at the graph. So when given the chance to, graph it on the calculator, graph it by hand, and get a visualization of what the range is. Now let's take a look at a slightly more odd-looking function. This here is also a piecewise function. The way that we can tell is because you can randomly see random pieces of functions in it. And let's actually find the domain and range to this function. Remember that if we're looking for the domain, we want to look along the whole x-axis and see what points the function contains. Let's work our way from left to right. That means that we're going from smallest to biggest. And what we can see is that this function, the first x value that it has is 1. And since it has a closed circle, we are including 1, so we need to put a bracket. And let's continue this line and see where it goes up to. If we follow the line, we can see that there is a hole at 2. So we can write down our 2 and write a parentheses around it, because we write the parentheses and unions whenever there is a hole, gap, or break. And then from 2, it's continuing from 2, and then it goes up to 3. At 3, we also have another point. So we have to put a parentheses, meaning that it's not included, and the union sign. At this point, the graph stops. There's a break, so we need another union. And now let's see where it continues. There's a dot at 4, a filled-in circle. So that means that 4, the point 4, is being included. And it only has to be included at only one point for it to be on the domain. So 4 is being included, so we need a bracket around 4. And let's see if there's any point on this 4 line that it continues. It continues down here. Down here, we can see that the graph is continuing up until 5, and at 5, it stops, but it's filled in. 5 is being included. And from here, we can actually see that it continues on from 5, down at the bottom at -1. Since it's included at 5, and it continues to be included up until 6, we do not need to write the 5. We can say that our graph is continuing all up until 6, and that is where it stops, and it is being included as well. So all the points from 4 to 6, all the x values, are being included. So this is our whole domain. Now let's look at the range. The range is something similar, but this time we're going to be looking at the y-axis. So when we look at the y-axis, let's see what values we get for our y. So we're going to work our way from the bottom to the top, and at the bottom we can see that our function is starting off at -1. And since this is a single point, because after 1 it doesn't seem to go anywhere, there are two ways that we can notate this. We can say that we are including 1, and that is going up until -1. We put brackets around it because we are including this point. And then after this, we can write union and then everything else that follows. Another way that you can write this is by including squiggly brackets and saying that this is one point that is being included and unioning it with the rest of the range. So let's continue with the rest of our graph. Let's see what else is part of our range. If we continue along the y-axis, the next point that has a value is at 1. 1 is being included. So we have to put a bracket and a 1, comma, and then let's follow up until where it goes. If we choose to go along this function, then we can see that this has a solid line throughout this whole part. Since it has a solid line up until 3, that means that every point in between 1 and 3 is being included. So this is going from 1 to 3, but 3 is not being included. So we need to put a parenthesis around that. And so that basically covers all this area. We don't even need to worry about the rest of it. Because remember, as long as the function has one point being included, that is okay. And that means that it is part of our range. It is being included in our range. So this is generally how you can always find the domain and range given a graph. I hope this clarified any questions that you guys had about piecewise functions. Remember to subscribe.